In this tutorial, we're going to talk about logarithms and specifically how to rewrite them and how to evaluate them. So first of all, I need to write out a general rule for them. And there it is. This is a huge rule for logarithms. And this is how we're going to rewrite them. So first of all, I want to make sure that we understand where everything is coming from. So if I start with an exponential function, this is the y equals b to the x part, I will have a y, okay? It will be the y that is over here on the log part. If I have this b, that becomes my base here. And my x will be written on the other side of the equal sign. So the best way to practice this is just by doing examples. So let me get rid of all those other marks, and we're just going to jump right in. So here is my first example. It reads 25 equals 5 squared. So that is definitely a true statement. And now I'm going to make this double-ended arrow. And what that means is that this function can be written in another way and vice versa. So basically what's on the other side of this double arrow is the same exact thing as I have here, just written as a logarithm. So we're going to first start off doing the logarithm by writing the log part, and now we got to figure out what our base is. So if I follow my rule, my base should be right there, so it's the 5. So I'm going to write that a little bit lower than my log. The y part is looking like it's going to be on this part of my equation. So then I'm going to write the 25 up here like that. And then that's going to be equal to whatever the exponent is right here, which in my problem would be 2. And that would be the answer of just simply rewriting this. That's all I have to do. So I'm going to put another one up here on the same exact page, and I'm going to tell you when to pause the video, and then I want you to see if you can do it on your own. So here's my second example. So it's going to start this way this time. I'm going to have 729 equals 3 to the 6th power. So I would like you to pause the video and see if you can do this on your own. And the correct answer is log. Your base in this case is going to be 3. Your value of b, or your value of y I should say, is 729, and it should be equal to 6. So if you didn't get one of those parts right, go back and make sure that you understand where each part came from. So now, what if I ask you to evaluate a logarithm? Evaluate simply means to solve for x. And when you're given some of these problems, they're not going to have an x built into it. But I know simply by looking at this part here that it should be equal to an x. So I'm going to come down here and I'm going to manually write in an equals x. This will happen. You're not going to always be given the problem with the equals part in it. So you have to write that in for yourself. The way that I'm going to solve this, I'm going to solve this without using a calculator by rewriting it as an exponential function. So I'm going to go from this log form to this exponential form. So I'm going to first get my y. And if I follow the pattern over here with the log base b of y, then that means that the 64 is what I need. So 64 equals b to the x. So where's my base? And my base is really easy to find in logarithms. It's the only number that's written as a subscript. So that would be 8. And then my exponent is an x, and over here it's still an x. So what I need to do right now is think to myself, what would I have to do to 8? What exponent would I need to get me to 64? And the answer would be 2. So that's one way that you can evaluate logarithms. Let's look at another one. Okay, so let's take a look at this one. I'm supposed to evaluate the log base 4 of 8. So I'm going to write in my equal x part, and I'm going to get straight into rewriting. So I need y equals. So my y over here, my logarithm is the 8. So 8 equals. My base is a 4, and my exponent is going to be x. Now you have to be really careful right here because your answer is not 2. When you raise 4 to a whole number exponent, you're never going to get 8. So when you run into this situation, you want to think to yourself, what can I replace an 8 and a 4 with so that I can possibly rewrite it in a different way? And this can be a very tricky part. So I want to break 8 down, and I want to break 4 down. And I want to try to think of this as cubes or quadratics. So either something cubed or something squared. Now with 8, I know that 8 can be the same thing as 2 cubed. Okay? There's nothing that I can square to get 8 as a whole number. Now, can I break 4 also down into 2 to some power? And the answer is yes. 2 squared is the same thing as this 4. Okay? Now, the x on the outside is still going to stay there. So here's what's really cool about this part. And actually, let me clean this up real quick before we go any farther. So 2 cubed, I'm going to keep as is. And then over here, I have 2 to the 2x. So, like what I was going to say, this is the cool part. Since my bases over here are identical, the only thing that's going to make this equation work is if this 3 is equal to this 2x. So I have to actually build a separate equation. And it's not that it's hard, it can just be a little confusing at first. So in order for me to solve this, I need to divide both sides by 2, and there we go. My answer is x equals 3/2 or 1.5. Let's do one more like this. Okay, so here we go. We are going to evaluate the logarithm of base 9, 27. And once again, we are going to go in here and add in our equals x. So we're going to rewrite. So I need y equals, so that's going to be 27 equals b to the x. So my base is 9, and then I have x as my exponent. Now, once again, I cannot raise 9 to a whole number to get me to 27. You just can't do it. So we have to think to ourselves is what can my base of these numbers be instead? Can I cube root them? Can I square root them? And the answer is that I can do neither. So we have to figure out what to do. I know that 27, it's not going to be, that can't come from something being squared. So 27 can be 3 cubed, but it can't be anything squared. So let's try to think of 9 as a 3 as well. So what would I have to do to 3 to get to 9? And in that sense, it needs to be squared. So I can't think of any other number besides 3 that I can raise to an exponent to get either one of this number and this number back. So this is going to have to be how we rewrite this. And when we do that, I'm going to write it just as it is over here. So 3 cubed equals 3 squared to the x power. So I'm going to clean this up, and I'm going to say 3 cubed equals 3 to the 2x. And this is going to work out just like the problem we did previously. We're just practicing it in a different way. And that is that my exponents have to be identical. So I'm going to run into this 3 equals 2x business again. And that, of course, leads to my answer being 3/2 or 1.5. And that will conclude this tutorial.